So in the last lecture, we have discussed basic Pinacolone rearrangement, and we have seen some rigid system and some non-rigid system in Pinacolone rearrangement. But this is a special kind of substrate where Pinacolone rearrangement is found. This is alpha hydroxy epoxide compound. Alpha hydroxy epoxide compound. Why alpha hydroxy? This OH is hydroxy and this whole system is epoxide. This is basically oxyren. This is epoxide type of compound. So alpha position OH, alpha hydroxy epoxide. Before going into that, let me check how much you have revised basic Pinacolone rearrangement. We have studied two type of system where Pinacolone rearrangement can occur. One is non-rigid system, one is rigid system. There are three type of substrate in non-rigid system. First one in adjacent position, suppose group 1, group 2. In first case, what were the groups? Hello?
Yeah.
In first case, what were the groups? And what was the reagent? In second case, what were the groups? What was the reagent?
I'm not able to recollect.
First one, it was both OH, second OH, NH2, then OHX, and first one H plus was reagent. So this was getting deprotonated. Second, it was diazotization. Here N2 will form. Reagent was HNO2, and N2 will remove, and here carbocation will form. Third case, halide. Then silver nitrate was reagent. Okay. So here our substrate is alpha hydroxy epoxide. Let's see what are the reagents and how this system can perform Pinacolone rearrangement. The basic requirement for being for a Pinacolone rearrangement is there is one OH group and adjacent position there should be one carbocation. Now this alpha hydroxy epoxide compounds, if we treat with Lewis acid or acid, so it undergo Pinacolone rearrangement. Lewis acid, they can be SnCl4, ZnCl2, AlCl3, BF3, etc. So normal Lewis acids or any acid. What will happen? First, Lewis acid, in case of Lewis acid metal and in case of acid H plus, will coordinate to this center. So Lewis acid. So what will happen? Lewis acid, oxygen, complex will form, oxygen will be positive. Now what happens? Here is our OH. Now here what will happen? This bond will break. We have discussed already in ring opening of epoxide that in Lewis acid or in acidic medium, the process is SN1 type. So here what happens? Oxygen Lewis acid plus OH. Now the same condition I found, OH at the adjacent position, carbocation. Then what will happen? Here a group, both are hydrogen. Then hydrogen will migrate to this center. So our final product will be with workup O Lewis acid will be OH basically. So at this center there will be hydrogen and there will be double bond OH. So here the product, always product will be beta hydroxy aldehyde or carbonyl, not aldehyde, carbonyl. beta hydroxycarbonyl will form. Okay. Now if we provide heat, then this molecule will form after dehydration. Okay. Now do yourself with this substrate. Tell me what will happen, what will be the product.
Okay. Is it only after the first step or after heating also?
Not after heating. Generally the reaction stops here. This is the Pinacol
Okay.
Pinacolone rearrangement product.
Okay.
uh, to do the reaction in very first way, as you know the mechanism, then actually what you can do like this. And if these two group are different considering migratory aptitude, then suppose this group will migrate here and here. Okay, this is the actual process. The whole mechanism is like this only, right?
Yeah, I got that.
Okay, so here methyl, here OH, here also one methyl, then C double bond O CH3, right?
Yeah.
Now another question, little more difficult. BF3, reagent is BF3 dot Et2O. Generally, for some reactions, normal BF3 is given. It is basically Lewis acid, but actually BF3 is always associated with Et2O, BF3 Et2O complex. Okay, so what should be the answer?
Will
Try.
there be a ring expansion in the this four member ring?
You know, this is Pinacol rearrangement. Then here carbocation will form. In this center, carbocation will form. Then is there any another way or any another process without ring expansion? Obviously, it will be ring expansion. This the difficulty here is making the rings. Okay, I'm writing the product. Just match this. Is it the product? Have you done this? Is this the product?
The carbonyl group, I'm not getting it over there. I'm getting it to the adjacent position next to that, towards right side.
Now this center is basically this center. Now this center is attached to this carbon. This bond is same, right? This, and here there will be double bond O. That will be adjacent only.
Okay, I'll try it once more.
Okay. Just after the class, just look at the problem. We'll able to get it.
Okay.
Next, now what examiner will do? They will not provide you the ready-made alpha hydroxy epoxide. First, they will give another reaction. They will prepare it by you. Now, How can you prepare epoxide? Just tell me one reagent. Tell me one reagent.
MCPA.
MCPBA, right? Okay. In this alpha hydroxy epoxide, we have to make epoxide and hydroxy. Hydroxy, how can you make? If there is one carbonyl compound, then RMGX, this will basically make alcohol, right?
Hmm.
So epoxide formation, you know, hydroxy formation, you know. Now the question is, this 5-member ring with one double bond, OH, 2 methyl, MCPBA. What will happen? Only MCPBA.
I'm getting a 5-member ring, OH attached at the base towards the right. Like, okay, after MCPB, it's just epoxide across the double bond.
The question is only MCPBA.
Yeah, yeah, sorry.
So this will be answer, right?
Hmm.
This will be obviously given in the option, but it will not be the answer. Why? The answer will be OH, methyl, double bond of methyl. This is basically rearranged product, right? Pinacol, pinacolone rearranged product.
Yeah.
Then there is no reagent like Lewis acid or acid, isn't it? This is
Hmm.
basically an acid, metachloroperbenzoic acid. So this will eventually act as acid here. Okay.
Okay.
Hmm. Now another question. 5-member ring, epoxide, for example, double bond O. RMGX, for example, CH3MGX. Second, H plus. Now what will happen? Try yourself. Are you getting this?
Just a minute. Yes.
Okay. Let's move forward to some difficult problems, more difficult questions. Mm, bridge. MCPBA. First, the epoxide. The epoxide will be like this. Why this epoxide? Not the it is the exo-oxygen, not the endo-oxygen epoxide. Because two hydrogen repulsion, if it is endo-oxygen, then these two hydrogen will be repelled by this methyl group. Okay. Now this is the first stage, the epoxidation. This is okay. Now it is a rigid system. And in last class, I have told you in rigid system, not the migratory aptitude, but the orientation that it matters. And I have shown you this bond will break and the parallel bond. If oxygen comes a double bond, then this bond This bond is parallel, right? So this bond will move here. So anti-periplanarity in rigid system always anti-periplanarity, not the migratory aptitude. So what will happen? Finally, we will be getting up to this point, it's okay. But after that, this center will move to this center. So this center will move to this center. Here we will have double bond O and 2 methyl. And at this center, there will be CH2OH. Right. Now it is a 2 to 1 bridge again. 1 2 2 1 and 1 2. This is again 2 to 1 bridge. It was also 2 to 1 bridge. Now if you write it like this way, this is a 2 to 1 bridge frame. Now this one system, there will be no group, and here this 1 and 2, there will be nothing. But here what happened, in one bridge there will be CH2OH, for example CH2OH, and the adjacent position will be C double bond O, and the next one will be 2 methyl group. Got it?
Could you explain the last step once more?
This transformation, right?
Hmm.
Here this is 2 to 1 bridge, because two center, and one center, 2 to 1 bridge. Now this overall framework, this is also 1 2 2 bridge, 2 and 1, 2 to 1. So I have just first drawn a 2 to 1 segment. Now this
Hmm.
one segment I have put this, suppose if I numbered the carbon, simply C1 carbon is C1 carbon. Okay. Now there is one vacant bridge position. This is bridge position, bridge 1 suppose, and this is bridge 2. So this is basically bridge 1 and this is basically bridge 2. Bridge 2 have CH2OH.
Yes.
Now after bridge 2 there are two vacant centers, this one, this one. With bridge 2 there are again two centers, but C double bond O is attached to this carbon, B2 carbon. So got it?
Yeah.
I have just tilted this whole structure like this way. Okay.
Hmm.
So with this, our Pinacolone rearrangement is over. Our next discussion will be on the final rearrangement associated to carbocation. This is dinone phenol rearrangement.